Hi, and welcome to Chapter 3. In Chapter 3, we're going to be covering a concept called Boolean logic. It'll be our decision making. If you've already taken a programming course, at some point you might understand the word Boolean. Yes or no, true or false, on or off. So we're going to do a lot with Boolean. And Boolean logic is going to help us to make decisions. We're going to be using ifs and elses in this chapter. Let's get started. The first thing we're going to talk about is decision making and control structures. So, basic question I want to ask you. If you get 70%, then you pass the class. Makes kind of sense, right? It's just logic. We understand this. We use logic like this every day. In programming, we use the same type of logic. When you're writing code, we use things called control structures to organize our code. The control structure will allow us to make sure we understand what is going to be processed when. So are we going to process this line or that line? What is going to be done in order? And how do we know what line of code is getting processed next? That is controlled by the control structure. A control structure can include other control structures. And a word that we sometimes use to describe a control structure is a block of code. We're going to use that phrase a lot, a block of code. And it's just going to be a subset of commands or things that we're going to be doing, assignments, statements in our code. And we put them all in some semblance of an order, and we allow the control structure to control that. Inside of our control structure, we have a decision structure, which is going to allow us to make decisions. When we do that, if you made 70% or more, you pass the class. That is a decision that we're making. And so when we write our code and we design our logic, we want to think of the decision structures that we need just to make sure that our code runs the way that we want it to run. To do that, the first thing that we're going to teach you is a single alternative if statement. Single alternative means that there's one option. If you get 70%, you pass the class. We're not going to throw an else or anything otherwise there. We just have one option because in this class, obviously you guys are all going to pass. We only have to worry about one direction. So we only have to think about one thing saying, if you make 70%, you pass the class. And it's a single alternative. There's just one alternative to go in there. When we diagram, remember we talked about using flowcharts for our diagramming. You can obviously in pseudocode write the word if. But if you wanted to use your diagramming, the control or the decision making in your flowchart is going to be a diamond. So this is going to be a diamond in the middle of your flowchart, like I have listed here, that is going to say, if this occurs, if it's cold outside, then wear a coat. And then we move on with our code because there is no alternative. We don't want to do anything if it's not cold outside. We don't have to worry about that. You can have multiple statements inside of your decision. So as you can see at the top where I have my x is equal to 5, if x is greater than or equal to 5, well it is because x is 5. Then print x is greater than or equal to 5 and hello world. We can have two statements in there, and that's fine. So the syntax that we use, remember syntax is the grammar rules that we're using for Python, is the word if, then our conditional statement, which is going to be a Boolean statement that will return either true or false. We're going to talk about how we can use greater than, less than, equal to compare things, or you could simply use the word true or false as a variable inside here. I like to put them in parentheses to make it clear. It's not required in Python. Some languages it is required, so it's a good habit to get into. But again, in Python it isn't required. You don't have to have parentheses around your condition. And then at the end of your condition, so we have if, parenthesis, if you're going to put them in, x is greater than or equal to 5, close parenthesis, and then we add a colon. The colon is going to tell the interpreter, this is the end of my if statement. Please, if this was true, run the pieces of code underneath this. Most important part about this, you'll notice that my print statements are indented. I've hit the tab button so for each one of my statements. With Python, it is indentation specific. It knows whether your items are indented or not. And the indent will tell you, run these lines of code underneath this if statement. In some languages, we use braces, curly braces, to determine a block of code. But in this case, the indentation is what tells you that it's a block of code. So in our top example where we say if x is greater than or equal to 5, the block of code that will run, if it's true, is going to be those two print statements. If it's false, it's just going to keep going. The code is just going to keep procedurally, linearly going down, skipping the entire if statement and the blocks of code that are indented and going down to the next statement if there is one. Okay. You can also see when I did my flow charting on this with the if it's cold outside, wear a coat, you can see with the diamond how the arrows kind of just go right off of one of the edges. So I can take the true and go off to the right hand side, and then I can do the false and go straight down, just showing you if it was true, go off and do this, otherwise just keep going. All right. With our relational operators and Boolean expressions, you'll hear me use these words a lot. The expression or the Boolean expression is simply that statement that determines whether or not something is true or false. That's all it is in a Boolean expression. There's a little thing up here on George Boole, who came up with the concept of Boolean, which is always kind of interesting. So when we think of Boolean expressions, we usually will think of mathematical expressions equal to, not equal to, greater than, less than. The not equal to is an exclamation mark with an equal. So the equal is two equals. Really important thing with equal. The assignment character is just a single equal. That means assignment. Is equal to is two equal signs next to each other. A lot of beginning programmers are going to get this mixed up. So when you are trying to do a comparison, you are trying to create a Boolean expression, you need to use the two equals. Otherwise, you're just setting your expression or your variable equal to whatever you're checking. So if I said if x equals 5, I'd be setting x equal to 5. It's a statement. It solved just fine and it'll always be true, whether x was 5 or not. You have to make it x equal 5. Otherwise, it doesn't make any sense. So a couple Boolean expressions I've given here, just x is equal to 5, y is less than or equal to 3, or z is not equal to 12. We like to use the exclamation mark to just say not in a lot of expressions. So if you have an expression that is going to return true or false, the not will flip that. So if you say not, parenthesis, x equal 5, that's the same thing as saying x is not equal to 5. We can use not as an expression of itself on the outside, or as an operator on the outside. So these are a couple of relational operators, mathematical operators that we use. You've probably seen them all in your high school math classes, and I mean, you know what they mean. So it should be pretty easy for you to understand comparisons if we're going to check numbers. All right, at this point, I'd really like you to stop the video for a second and go do the code on 116 and 117. You're just going to be printing out an average score, so you're going to take a couple of inputs, you're going to add them all together, and you're going to determine what the average was. So I've written the code here. You can copy it directly, or you can recognize what it's doing and not copy it and write it in your own version. But this way I want to make sure that you can get used to the idea of using inputs to get integers. Remember, we did that casting last chapter, so that you could do that. And then do that if statement. If your average is higher, greater than or equal to your high score, you'll notice I didn't have a magic number of 95 in there. I put that as a variable at the top. We like to get in the habit of doing that. You don't want to have just a random number in the middle of your if statement. If average is greater than or equal to 95, you want to define that as a variable somewhere in your code. And then you're going to go ahead and run it. So you're going to go into Python, you're going to go ahead and run that, make this into some code, and run it with a couple of different scores and see what it comes out as. Make sure that your if statement gets handled correctly. If it was not greater than or equal to the high score, did it just print the average and then move on? Or did it print the average and then still print, congratulations, this is a high score? Make sure that you have that colon at the end of your expression. All right, go have fun. And then when you're done, come on back. So hopefully that gave you a little bit of an example of working with if statements and you're kind of comfortable with it. So we're going to add the next part of it, which of course is the else. If you get over 70%, you pass. Otherwise, you fail. Okay, yes, that is technically an option, but I'd really like none of you to think of that as an option. These are called dual alternatives. In other words, there's two different ways that you could go. You could go to the if you pass, and you can go to the if you fail. So two different options. As we're speaking in normal life, you guys have all used an if else statement. You just may not have known that that was a logical statement that you can also use in code. In Python, the syntax for if else is, again, your if with your parentheses if you want to have them, your conditional statement, and a colon. Then again, tabbed in your decisions or your block of code underneath that if statement. Then tab back so that your if and your else are lined up. They have to be lined up in Python. Some languages don't care about white space. You could have your ifs and else all over the place. In Python, it's very important. They have to be lined up. So your if and your else have to be lined up. And you can see that little extra line in the VS Code. It tells me where they're lined up, which is kind of convenient from a visual point of view to let you know, just in case your if and else are 10 lines away from each other, you can still see where that little line lines up, so you can make sure that they're lined up together. So your if and else are lined up together, so you just use the word else and then a colon after the word else. You do not have to put in any type of conditional statement with your else. The compiler knows if it wasn't the first one, then it obviously has to be the else, because those are your only two options in a dual alternative situation. So if the temperature was 7, and we asked if the temperature is greater than or equal to 0, it's a nice day, and if it's less than 0, then it's a little chilly, because we're in Montana and that's what a little chilly means. So don't forget your colons after both your if and your else, and then realize you can have multiple statements under each as long as they continue to be tabbed in. That indentation really matters. All right, I know I just had you take a break, but I want you to do another one because I want you to do an if else. This one is also out of the book, page 120. Program 3-2, and it's going to do a payroll that is going to allow you to find the gross pay before taxes and the net pay after taxes. For those of you who have already worked, you'll understand what this means, the wonderful net pay after your taxes are taken out. So, but I've not given you the code here. There's some examples in the book, so if you go to page 120, you can walk through that, but I kind of want to see what you can do if you understand what the requirements are. It's an auto repair payroll. You're going to create some constant values for how many is a base hour, if it's 40 hours a week or whatever, and then what you're going to multiply for your overtime. So a lot of times people use time and a half for overtime. Some companies use different percentages. Time and a half would be multiplying the hours that are in overtime by 1.5%. And then you'll get however many hours in overtime. So take your inputs from your user so that your user is asked, how many hours did you work? And what is your hourly pay rate? If you're over the base hours of 40 hours, figure out how many hours were overtime and figure out your overtime pay, and then be able to get your total pay. And then finally, go ahead and print your gross pay at the end. We're not doing the calculation with net pay for this lesson. We're just going to get the gross pay with overtime. So go ahead and have fun with that one, and then come on back when you're done. So we're going to go off of a little bit from if-then statements to just explain about how we do comparisons with strings. Comparisons with strings can be done exactly the same way as numbers are, with an equal sign. However, you need to remember that capital letters are not the same as lowercase letters. Remember, a capital A is a 65, whereas a lowercase is a 97. Completely different numbers. So a capital A is not a lowercase a. When you compare strings, you can use that equal or the not equal. But if you wanted to do comparisons with greater than or less than, we'll use those for sorting, because that'll tell us that an A is less than a B, for instance, for the purposes of comparison. But most of your comparisons with strings are going to be equals. Is this the equal to whatever string I'm going to pick? Remember also that ASCII characters not only compares your capital letters, your lowercase letters, it also has all of your special characters. So you can go back to that ASCII character string or ASCII character list and look at what the character number is for each of those special characters as well. All of those are considered strings for the purposes of comparison. So just as a quick thing on comparing strings. In some other languages, assuming you have any interest in going into programming in the future, recognize some languages will not let you compare strings directly. You're going to have to do some sort of operation on them. But in Python, we like to make it easy for you. So you can just compare them with an equal sign. All right, so now we can get to a tertiary or third option in our if-then statements or if-else statements. We have talked about doing if, and we have talked about doing else, but we have not talked about what if I have multiple options I want to check. So in this case, I have done if my score is less than 90, then, and I'm nesting, if my score is less than 80, then, if my score is less than 70, if my score is less than 60, then give me an F, otherwise give me a D, otherwise give me a C, otherwise give me a B, and otherwise give me an A. These are nested ifs, and I always refer to them as nesting dolls, like Russian nesty dolls, because they are nested. They're inside of each other. So the small if else statement in the middle is comparing D's and F's, but every other if in there is comparing the rest of your grades. You don't have to use nested ifs because we have an alternative in Python using an else if. We shorten it to elif, E-L-I-F, so elif as opposed to E-L-S-E space I-F. And we can just say elif for each of those options. So I can say if my score is greater than 90, then I have an A. Else, if my score is greater than 80. Well, I know it wasn't greater than 90 because I wouldn't be at this point if it was. So in this case, it must be less than 90 and greater than 80. So then I know I have a B. Else if my score is greater than 70. Again, I know I'm less than 80 because if I was greater than 80, I would have been picked in the previous two options. So I know I'm between 79 and 70. So then I know I have a C, and so on and so forth. And then my final else is the final one where if none of the other choices were done, then we can do our else. It's our default case. So this case, you can do a series of conditions all lined up nicely. Don't forget your semicolon or your colon at the end of each if statement. So else if conditional colon, else if conditional colon. So don't forget that. Let's keep going. Sometimes in programming, we want to compare multiple things at the same time. So in the previous example of nested ifs, you saw that I didn't say specifically, is it less than 80 and greater than 70? I just used my if else or my else if to determine that. In this case, we may want to compare two completely separate things. Is A and B, or is A or B? So these are options. These are our logical operators, and they will help us to connect multiple Boolean statements into a compound expression. Remember, compound words where you take two words and you push them together. In this case, we're taking two expressions and we're pushing them together. And I've given you the decision tree here, or the truth table here. If you use an and, both of your expressions must be true for it to be true. Otherwise, it's false. So with an and, there is one true condition and three false conditions. If they're both true, it's true. Otherwise, one is false, the other is true. The first one is true, but the other one is false, and otherwise they're both false. So all three of those possible false conditions with an and. With an or, there are three possible true conditions with one false, because either A or B can be true. They can both be true, and those will all result in a true. Otherwise, it's false. So there's only one false condition. And then finally, a not. A not just flips whatever you're asking. So we can do a not A, and it'll either be true or false, whether or not A is false. If A is false, not A will be true. If A is true, not A will be false. We use logical expressions a lot. Just to do comparisons between multiple things at the same time. We don't want to have to do 5 different else or if statements if we can keep it all combined in one expression. So we use these a lot. You're going to use these in your homework. All right, the last thing in this chapter before we get into the homework exercises are Boolean variables. You can create a variable that is a Boolean value, true or false. In this example, we have used the variable past, and we have set it to the value of score is greater than 70. So if score is greater than 70, past now becomes a Boolean value of true. If your score is less than 70, passed now has a Boolean value of false. Now I can just use passed as a conditional in my if statement all by itself. It makes things very clean in your code to be able to create a Boolean variable and then use that variable inside of your expression or inside of your conditional option for your if statements. So in this case, instead of saying if score is greater than 70, I can just say if passed, go do this. Otherwise, go do that. And it allows us to do that with a variable. We also like to use this as a signal or a flag or a sentinel. When we're going to get into loops and when we're going to get into some further options, you're going to see places where using a Boolean expression gets a little clumsy, and using a Boolean variable will allow things to be easier. When all of these things occur, set let's keep going to false, something like that. But we'll get into that when we get more into it. But I want you to understand you can use a variable to store a Boolean value of true or false. Let's talk about your homework. All right, so on top of the quiz, please do not forget to do the quiz. There are 3 exercises for this chapter. Might not sound like a lot, but I want you to think about them, and I'm not giving you the answer to them. I'm just letting you go with it, because at this point, you should have enough knowledge in your head that you can write the code without me telling you the code. For the first one, you are going to find the area of a rectangle. It's exercise 2. So you're going to write a program that asks for the length and the width of 2 different rectangles. So envision that you have 2 rectangles. You're going to ask your user, what's the length of one, what's the width of one, what's the length of 2, and what's the width of 2. Then you're going to calculate the area of both, and you are going to print out which one has the larger area. You're going to have to use a decision for this. So you're going to print out the area of both, and then you're going to say, rectangle 1 was bigger, rectangle 2 was bigger. They're both the same. A couple of different options that you have there, so you want to check those. That's your exercise 2. For exercise 6, we have a concept of a magic date. Okay, it's kind of hokey, but the example of a magic date is where you can take the day and the month, multiply them together, and get the 2-digit year. So in this case, 6/10/1960 is going to get you a magic date, because 6 times 10 is 60, and 60, 1960, 2060, however we want to do that. The 2nd of October, so 2/10/2020, is going to get you a magic date. What you're going to do is you're going to write a program that asks the user for the day, the month, and the year. You don't have to ask them for all 3 of them and then parse out which one is which. You can just say, what is the day, what is the month, what is the year? And then you're going to calculate whether that is a magic date. If it is, you're going to say, this date is a magic date. If it's not, you're going to say, this date is not a magic date. Okay? So that one's going to use a little bit of math, a little bit of calculating, and then again, a decision. Finally, your last homework assignment, and this one's a little bit more challenging just because it's a little more complicated. A basic roulette wheel, because in programming we love using casino logic. Basic roulette wheel has numbers on it between 0 and 36. The 0 is green, and the 1 through 36 alternate between red and black, but they don't alternate straight. They don't do all even numbers are red and all odd numbers are black. They actually have a little bit of a different thing, where if you're in the group between 0 or between 1 and 10, the odds are red and the evens are black. If you're between 11 and 18, then the odds are black and the evens are red. Then back to 19 through 28, the odds are red, the evens are black. And 29 through 36, odds are black, evens are red. So it's flipping. So you have to do a couple of different decisions. Which group are you in? Are you in the 1 to 10, the 19 to 26? You're going to have to do some comparisons. You're going to ask your user for a pocket number, and you're going to say what the color of that pocket is. Okay, so again, a little bit of mathematical computation here. Which one is which? Figuring out which pocket you're in, whether or not that is going to be red or green. Try to make your code as clean as possible. You could do this brute force. If you're in pocket 1, you are odd, so you must be red. If you're in pocket 2, then you're even, but still in that group, so it's black. Back and forth. Please don't do that. Try to find a way to make it cleaner than that, using some logic, using the knowledge that you have to try to figure out if your numbers are between this and this or something along those lines. I decided I wanted to have you do one project with turtle graphics. The code for a lot of it is already in the book, so it's not going to take a lot of effort, but it is going to get you a little bit more used to using the turtle graphics. I would like to include a turtle graphics with each chapter from now on, just to make sure that you're getting the visuals of it. And sometimes the turtle graphics can be fun. So after a lot of programming, it's always good to remember programming is fun. Let's have fun with this. So we're going to do exercise 19, which is the last exercise in the chapter. Now they've taken the program that they've written for you in at the back of, or at the end of chapter 3. So it's project 3.9, which is a hit the target, where you give a specific X and Y coordinate of a target, and then you have a little turtle that you're going to ask the user what angle do you want to go at and what velocity, so what force, and then you're going to move your little cursor across the room to make it hit the target. So it's kind of a fun little project. And then the exercise itself is just going to be at the end of that code where you say whether you hit the target or not. If they didn't hit the target, give them some examples of what they did wrong. Like your angle was too low, your angle was too high, your velocity was too low, your velocity was too high, so on and so forth. So just have a little bit of fun with this one. These are some fun projects, so I want you to go have a little bit of fun with it. You're going to type them up. If you would like to, you can type them all up in the same Python file and then submit that file, or you can submit 3 Python files. Either way is fine. I don't mind either way. I'm still going to run them both. So remember, if you want to write them all in the same file and then you want to comment out, say you've already done problem 2, comment it out. You can do that. Remember, those comments are hashtags or pound signs in front of all of the lines of code, and that will allow you to comment. I hope you guys are having fun and have a great week. We'll talk soon.